we have given an example. According to that example, a sphere is moving in a fluid due to its weight. So weight of the sphere acting downward, mg Newton. The liquid gives a vertically upward force which is known as upthrust, R Newton. In addition to this upthrust, a friction force is given by the fluid which is known as viscous friction force. So this velocity of the sphere is u meter per second. So this is a small sphere. Small sphere. According to Stokes' law, we found that viscous friction force. If you are absent last week, listen carefully, you can understand everything. That's why I play the recording. That's why I'm revising this one. If you are a new student, if this is your first day or if you didn't join last week, listen carefully, you can understand. Believe me. Right. This friction force given by, normally in O levels we learn weight of the sphere and then normal reaction upthrust, Archimedes principle. Right. Here, the new thing that we learned in advanced level is the friction force given by the fluid. I have marked it as capital F. Right. This viscous friction force can be found by the equation 6, 5, neta AU. U is the velocity, A is the radius of the sphere. Right. Last week we have simplified this expression and we have obtained an equation for F. The viscous friction force is given by 1.32 into 10 to the power minus 1.32 into 10 to the power minus 2 Newton is the viscous friction force. If you apply the value of 6, 5, value of meter, value of radius. And here, sorry, velocity will be into the velocity of the sphere. We found this last week. Right? So I think you can substitute the numerical values and find. Right? We obtained this this answer last week. We got it last week. Okay. Right. Then we found an expression for the volume of the sphere. Volume of the sphere. Volume of the sphere was found as 4.2 into 10 to the power minus 6 cubic meters. So this is the volume of the sphere. We found these two values last week. In addition to this, we have found an expression. We have found the upthrust also. The upthrust acting on the sphere is R equals, we have found it last week, 5.04 into 10 to the power minus 5.04 into 10 to the power minus 2 Newton. We found this data last week. What are things that we have found here? What are things that we have found? Volume of the sphere as 4.2 into 10 to the power minus 6 cubic meter. Viscous friction force given by the fluid as 1.32 into 10 to the power minus 2 times U. U is the velocity of the sphere. R is 5.04 10 to the power minus 2 Newton. Right. Those are the things that we have found. In addition, they have given us some data. They have given the density of the sphere. Density of the material of the sphere is given as 1,600 kilogram per cubic meter. Density of the liquid. Density of the liquid that the sphere is moving is 1,200 kilogram per cubic meter. So if you are a new student, write these things. Write the draw this figure and write down these things. If you are a new student, you can complete the note because I think I have sent all the notes to your WhatsApp groups. So you can complete the notes later. Start it there. Yeah, it is said that only 6 pages should be left. It means 6 pages or 12 sides. 6 pages or 12 sides. It's better if you it like that. As I remember, it's 12 sides. Right, whatever it is, please start writing these things. Then let's try to complete this example homework. After that, let's go to the next theory part. So like this, you should have a complete understanding about units and dimensions lesson, right? If you learn only how to build new equations or check the accuracy of equation using dimensional analysis, it means you have wasted your time. You have wasted your time. You should learn the real things asked in real examinations without wasting the time. So after I discuss this one, we start vernier caliper. We have divided a book into 2 half sections. One half is used for, half of the book is used for units and dimensions lesson. The other half is used for the vernier caliper. That's how we arrange the book. Okay, dear, we take the book. We have divided the book into 2 halves. One half for units dimensions, the other half for the vernier caliper measuring instrument. And we have another book. That book is used for Tuesday night class 8 to 11 to learn mechanics. Okay, dear. So it means 6 hours per week for the theory classes. Right. I think vernier caliper we have stopped with the reading. So today we can complete that lesson. Teaching half is not covering the syllabus earlier, right? So please remember it. Right. We want to find the mass of the sphere. To find the mass of the sphere, I can use this equation. Look at what we know that density equals mass over volume. Mass over volume. We know this equation. I'm going to apply this equation to the sphere. Density of the material of the sphere is given as 1600. So mass of the sphere is simple M. Volume of the sphere, we have found this. What is it? 4.2 into 10 to the power minus 6 cubic meter. So let me take it to this side. 1600 into 4.2 into 10 to the power minus 6 equals simple M. So then you get simple M equals, we have to multiply this. Complete it here. If video is not clear, please tell me, right? I can help. We should multiply 1600 by 4.2. If you multiply 1600 by 4.2, you will get 6720. 6720. In addition, we have this 10 to the power minus 6. Unit is kilogram. But we don't keep answers like this. Let me take 3 decimal points as 1, 2, 3. With this positive 10 to the power 3, 10 to the power minus 6 will be 10 to the power minus 6. You see, this is a positive value. So 10 to the power minus 6, 10 to the power plus 3 means 10 to the power minus 3. So M equals 6.720 into 10 to the power minus 3 kilogram. It means 6.72 grams. 6.72 grams. Who got this answer at home? Anybody in the class? Okay, very good. Very good. I'm so happy. Right. Then we can find then we can find the weight of the sphere. Then you can find the weight of the sphere. If we know the mass, weight of the sphere can be found by this equation. Weight of the sphere. Weight of the sphere means the gravitation attraction force given by the earth, that is mg. Weight of the sphere means mg. M is this one, 6.720 into 10 to the power minus 3, g is 3. So then if you multiply 10 to the power minus 3 by positive 10, so then minus 3 will be minus 2. So the weight of the sphere is 6.720 into 10 to the power minus 2 Newton. Who got this answer also at home? Okay, very good. So three forces are acting on the sphere, R, F, and mg. The sphere is moving under the influence of these three forces. As weight is larger than the other two forces, 5.0 something, viscous friction force 1.32 something. So as weight force is, as mg force is larger than the other two forces, the sphere will be moved downward. So we can find the resultant downward force. We can find the resultant downward force. The resultant downward force. The resultant downward force equals, the downward force is mg. We should subtract the upward forces. There are two upward forces, R and F. What are the upward forces there? R and F. Therefore, total downward force is downward force minus summation of the upward forces. Summation of the upward forces. Resultant downward force equals downward force minus summation of the upward forces. So we have found that mg, let me remove the brackets first of all, minus R minus F. mg, we just found it. What is mg here? 6.720 into 10 to the power minus 2 minus R upthrust here, 5.04 into 10 to the power minus 2 minus F. What is F here? 1.32 into 10 to the power minus 2. Can you sub minus 2 and u is equal to that? Minus 2 into velocity of the sphere, that is u. So as there is the term u, we can't subtract the value of the term with the u, but other two terms can be subtracted. The term with u cannot be changed, but other terms can be subtracted. Right. No, 6.720, this 0 not needed. 5.04. If you want, you can write this 0 here. 2 minus 4 can't. You have to take 1. 12 minus 4 is 8. Now this is 6. 6 minus 0 is 6. 6 minus 5 is 1. 1.68 into 10 to the power minus 2 minus 1.32 times 10 to the power minus 2 into u. So this is the final expression for the resultant downward force. Write them all here. Please mute your mics here. Right. Now we can find the resultant force of the sphere acting on the sphere when the sphere is moving with different velocities. Can you understand? We should find the resultant force acting on the sphere when the sphere is moving with different velocities. Right. Let me use this symbol for the resultant force, F res. Right. So resultant force. Right. I'm going to find the resultant force of acting on the sphere when the sphere is moving with a velocity of 0.1 meter per second. So resultant force acting on the sphere is given by the equation 1.68 into 10 to the power minus 2 minus 1.32 into 10 to the power minus 2 times u. So this is the equation, right? If we check this equation, these values are given. Let me put the equation mark here to save the space. Let me put the equation mark here. I want to save some space. 1.68 into 10 to the power minus 2 minus 1.32 10 to the power minus 2. Now u is 0.1. U is 0.1. So 1.68 into 10 to the power minus 2 minus 1.32. 10 to the power minus 2. 0.1 can be written as 1 over 10. Can you understand this math? If you divide 1 by 10, answer is 0.1. Now, I divide this 1.32 by 10. Now, I divide this 1.32 by 10. So, then what's the answer? 1.68 into 10 to the power minus 2 minus, if you divide this 1.32 by 10, if you divide 1.32 by 10, it will be 0.132 into 10 to the power minus 2, right? So finally we will get 8, sorry, this 2 is there, I have to take 1 to the side. 10 minus 8, 10 minus 2 is 8. This is 7. 7 minus 3 is 4. This is 6. 6 minus 1 is 5, and nothing will happen to this one. 1.548 and 10 to the power minus 2 will be there. 10 to the power minus 2 will be there. 10 to the power minus 2 Newton. So this is the resultant force acting on the sphere when the velocity of the sphere is 0.1 meter per second. Complete it here. Is there anybody who got this answer at home? Anybody in the class? Because this is the homework. Then how do we find the acceleration there? We may find the acceleration of the sphere under this, when the sphere is moving with this velocity, right? Let me apply F equal ma to the sphere, so we can find its acceleration, right? So we found the resultant force acting on the sphere when the velocity of the sphere is 0.1. We have found it 1.548 into 10 to the power minus 2 Newton. So we found this. Right. Now I'm going to apply F equal ma to the sphere vertically downward. The downward resultant force acting on the sphere, we have found it 1.548 into 10 to the power minus 2 Newton. Mass of the sphere 6.72 into 10 to the power minus 3 into acceleration. Right? So if I take this to this side, if I take this 6 point value to the other side, 1.548 into 10 to the power minus 2 divided by 6.72 into 10 to the power minus 3 equals 8. So if you divide this, we have this 10 to the power minus 3 will comes up 1.5. That's a very simple method. Let me give us another method to simplify this. Look at board. 1.548 can be written as 15.48 by taking a decimal place to the right hand side. Then 10 to the power minus 2 will be 10 to the power minus. Would like if I explain that mathematical simplification, this mathematical simplification. 1.548 in 10 to the power minus 2 can be written as 15.48 into 10 to the power minus 3. Would like if I explain that mathematical simplification method. Anybody in the class? Right. Okay, that is simple maths. It can be explained something like this. Look at board. Look at board. First of all, I'll write the weight of the sphere here because 6.7. Right. Let me explain it like this. Right. It can be explained like this. Listen, what's the number here? 1.548 into 10 to the power minus. Right. This can be written as 15.48 divided by 10. And I don't do anything to 10 to the power minus 2. Are you okay with this thing? Are you okay with this? 1.58 can be written as 15.48 divided by 10. Are you okay with that simplification? First tell me. Or should I explain that one also? Would like if I explain that one also? 1.548 into 10 to the power minus 2 can be written as 15.48 divided by 10. 10 to the power minus 2 will be there. It is not changed. Now, so simple. Now, one more step. 15.48, 10 to the power minus 2 divided by 10. Right? So, it can be written like this. Let me write two more steps. 15.48. This 10 comes up with the minus sign. this 10 comes up with the minus sign, 10 to the power minus 1. And additionally, there will be 10 to the power minus 2. Can you understand? The denominator 10 comes up with the minus sign. So 10 comes up as 10 to the power minus 1. 10 can be written as 10 to the power plus 1 if you want. If you want, you can write this 10 as 10 to the power plus 1. So 10 to the power plus 1 comes up as 10 to the power minus 1. 10 to the power minus 1, 10 to the power minus 2 means 10 to the power minus 3. 10 to the power minus 3. You will learn this many such mathematical simplifications in future. So don't worry about these mathematical simplifications. You can write this as a note later. You can write it later, but not now. Right. Okay. Right. Look at board. Now I have written this 1.548 10 to the power minus 2 as 15.48 into 10 to the power minus 3 divided by this 6 number divided by 6.72 into 10 to the power minus 3. Now you see the beauty. 10 to the power minus 3, 10 to the power minus 3 cancel now. I want to cancel now. That's why I have written this minus 2 as minus 3. Then only I have divided 15.48 divided by 6.7. Please complete this, get the answer, and write this note also. And if you have still difficulty, if you have any difficulty with this mathematical simplification further, send me a message. I can help you very well. Let's try to do the same thing. And you can find so many similar questions in your past papers and school term test papers. Let's discuss them also. You will find so many similar questions in your school term test papers as well as advanced level past paper questions. Right now, let us take the velocity as 0.2 meter per second. Then the resultant force. Let's try to find the resultant force. The resultant force equation is this. What? 1.68 into 10 to the power minus 2 minus 1.32 into 10 to the power minus 2 multiplied by u. U is the velocity of the sphere. U is the velocity of the sphere. We have obtained this expression already. Now we are using this expression under different velocities such as 0.1, 0.2, 0.3, 0.4, and so on. So then let me simplify this. 1.68 into 10 to the power minus 2 minus 1.32 into 10 to the power minus 2. U is 0.2. Right? So simple. So simple. 1.68 into 10 to the power minus 2 minus, let's multiply by 0.2. 2 times 2, 4. 2 times 3 is 6. 2 times 1 is 2. But how many decimal points should be there? 1, 2, and 0.2. Another one. 1, 2, 3 decimal points should be there. 1, 2, 3 mean decimal points should be here. This is 0.2. And nothing will happen to 10 to the power minus 2. Nothing will happen to 10 to the power minus 2. So let's subtract. Let's subtract 4. You have to take 1 to this side. 10 minus 4 is 6. Now this is 7. 7 minus 6 is 1. This is 6. 6 minus 2 is 4. And this is 1. 1.416 into 10 to the power minus 2 Newton is the resultant force acting on the sphere when the velocity of the sphere is 0.2 meter per second. Write it there. Write them all. Now we want to find the acceleration of the sphere. When the sphere has a velocity of 0.2 meter per second, what should be its acceleration? We know the resultant force. it can be found very easily. We apply F equals ma to this sphere. We apply F equal ma equation to this sphere. Vertically downward. The downward resultant force is 1.416 into 10 to the power minus mass of the sphere 6.72 into 10 to the power minus 3 into 8. Let me take that this value here. 1.416 into 10 to the power minus 2 divided by 6.72 into 10 to the power minus 3 equals simple A. Now, what should be the next step? I want to convert this into 10 to the power minus 3. This 1.416 into 10 to the power minus 2. I want to convert that minus 2 into 10 to the power minus 3. Somebody unmute the mic and tell me, how should I do it? The method.
1.16 into 10 to the power minus 3.
Very good, very good. We take one decimal point to this side. We take this decimal point to my right hand side. Then this will be 14.16. 10 to the power minus 2 will be 10 to the power minus divided by 6.72 into 10 to the power minus 3 equals simple A. Now minus 3 to minus 3 cancelled out. A equals, you have to divide this 14.16 and 6.7. Complete it there. Complete it there. And if you want any further help to understand this 14.16 and 10 to the power minus 3 numbers, just send me a message. I can help you. Send a Zoom message so I can help you. If you divide this, you will get the acceleration as 2.1. 2.1 meter per second. Now somebody unmute the mic and tell me what has happened to the acceleration when the velocity is increased from 0.1 to 0.2. What has happened to the acceleration? Somebody?
It has decreased.
It decreases.
Acceleration is
Acceleration
reduced.
is decreased.
Very good. Now my question is, what has happened to the next question? What has happened to the resultant force when the velocity is increased? Somebody?
Decreased. Decreased, sir.
Also decrease.
Velocity is decreased. Resultant force is decreased when the velocity is increased. Right? Then let's do the same thing when the velocity of the sphere is 0.3 meter per second. Let's try to do the same. Right. Right. If I write here, can you see it here? So now the resultant force. I think you can do it without my help. The resultant force acting on the sphere when the velocity of the sphere is 0.3 meter per second. The resultant force equation is 1.68 into 10 to the power minus 2 minus 1.32 into 10 to the power minus 2 times u. Can you do the rest here? Can you do the rest? 1.68 into 10 to the power minus 2 minus 1.32 into 10 to the power minus 2. U is now 0.3. Find the resultant force there. Try to find the resultant force. So what's the resultant force here? What is the resultant force? 1.68 into 10 to the power minus 2. 3 times 2 is 6. 3 times 3, 9. 3 times 1, 3. 1, 2, 3 decimal points should be removed. 1, 2, 3. Minus 2 will be there. Let's subtract. You have to take 1 from this side. So 8 will be 7 and this will be 10. 10 minus 6 is 4. This is 7. 7 minus 9 can't. Now take 1. 17 minus 9 is 8. This is 5. 5 minus, because we have taken 1. 5 minus 3 is 2. So 1.284 into 10 to the power minus 2 Newton is the resultant force. Who got this answer earlier? Who got this answer earlier? Right. Now we know the force. So we can find the acceleration. As we know the force, we can find the acceleration. So what should we do to find the acceleration here? To find the acceleration, when the resultant force is this much, we should apply F equals ma equation to the sphere. The total downward force acting on the sphere is 1.284 into 10 to the power minus mass of the sphere is 6.72 into 10 to the power minus 3 acceleration. Let me take this number to this side. 1.284 divided by 10 to the power minus 2 divided by 6.72 into 10 to the power minus 3 equals 8. How do I convert this 10 to the power minus 2 into 10 to the power minus 3? Somebody please unmute the mic and tell me.
12.84 into 10 to the power minus 3.
12.84 into 10 to the power minus 3, sir.
Very good. 2 students gave me the answer. Very good. We'll write this as 12.84 by taking this decimal point to the right hand side. Then 10 to the power minus 2 will be 10 to the power minus 3 divided by 6.72 into 10 to the power minus 3 equals 8. So minus 3 to minus 3, 10 to the power minus 3 to 10 to the power minus 3 cancelled out. Then we will get acceleration equals, we have to divide. We should divide 12.84 by 6.72.
1.9.
So what's the value?
1.9.
1.9. 12.84 divided by 6.72. Who gave me that answer? Very good. Yes, Putak, you are correct. 12.84 divided by 6.72 is 1.9. Yes, approximately. 1.9 is okay. Even for the examination, 1.9 will be. So what has happened to the acceleration? Is it increased or is it further decreased? Somebody please tell me.
Decreases.
Decreased,
It
sir.
has further decreased. So velocity increases, force decreases, acceleration decreases. Am I right? You have to draw graphs, right? That's why I'm taking time and teach this. You have to draw graphs for this section in the examination, right? Don't forget it. Now let's try to do the same thing. Let's try to do the same thing. When the velocity of the sphere is 0.4. I think that's the final thing asked in the question, right? So let's try to find the resultant downward force acting on the sphere when the velocity of the sphere is 0.3 meter per second. Start it there. Start it. Let's write it and try to find the resultant force acting on the sphere when the velocity is 0.3 meter per second. You were right.
So it should be 0.4 meter per second.
0.4. Yes. Yes, Pudha. Thank you, dear. 0.4. Velocity is now 0.4. 0.3 already completed. Yes, thank you very much. Right. Find the resultant force and the acceleration of the sphere when the velocity is 0.4 meter per second. Give a try. Okay, let's give a try. Resultant force is resultant force is 1.68 into 10 to the power minus 2 minus 1.32 into 10 to the power minus 2 times u. U is the velocity. So 1.68 into 10 to the power minus 2 minus 1.32 into 10 to the power minus 2. Now u is 0.4. If you are confused with this simplifying, you can write, if you want, you can write this as 1.680. You can add any number of zeros after it into 10 to the power minus 2. You will understand the reason for me to put this 0 very soon. Let's multiply. 4 times 2 is, so let me write 10 to the power minus 2 first. 10 to the power minus 2 first. 4 times 2 is 8. 4 times 3 is 12. 1 remaining. 4 times 1, 4 plus 1, 5. 3 decimal points should be removed. 1, 2, 3. 1, 2, 3. 3 decimal points. 0, the negative sign, minus. Now let's subtract. Nothing will happen to this 10 to the power minus 2. Now 0 minus 8. 1, 2, 3 decimal points. 1, 2, 3 decimal points. Even in previous cases, we can write 1, 2, 3 decimal points like that. If you are not okay with the simplifications. 0 minus 8 can't. You have to take 1 to this side. So this will be 7. This will be 10. 10 minus 8 is 2. 10 minus 8 is 2. Now this is 7. 7 minus 2 is 5. This is 6. 6 minus 5 is 1. This is 1. So 1.152 into 10 to the power minus 2 Newton. Who got this answer? Who got this answer? Right. Then we want to find the acceleration. You want to find the acceleration. So as usual, let me use the equation F equals ma. The total downward force is 1.152 into 10 to the power minus 2 Newton. F equals ma. F is the total downward force 1.152 into 10 to the power minus 2 into mass of the sphere, yes, 6.72 into 10 to the power minus 3 into 8. Let me take that number to the side. 1.152 into 10 to the power minus 2 divided by 6.72 into 10 to the power minus 3 equals 8. Now somebody unmute the mic and tell me how to convert this 10 to the power minus 2 into 10 to the power minus 3. Somebody in the class?
11.52 into 10 to the power minus 3.
Very good. This can be written as 11.52 by taking 1 decimal point to the right hand side. 10 to the power minus 2 will be then 10 to the power minus 3 divided by 6.72 into 10 to the power minus 3 equals 8. Now 10 to the power minus 3 to 10 to the power minus 3 cancelled out. Then you will get then we will get A equals, we should divide only 11.52 by 6.72. Let's divide it. 11.52 should be divided by 6.72. If you divide this, you will get 1.7. Acceleration will be 1.7 meter per square seconds. So what has happened to the acceleration? Huh? What has happened to the acceleration?
It has decreased.
So decreased further.
Decrease.
Acceleration
Decrease.
is further decreased. That's the point you should understand. Right? So when the velocity of the sphere increases, both acceleration and the resultant force are decreased, reduced. Okay, dear?
Excuse me, sir.
Yeah, I'm listening.
Sir, can we take as a uniform deceleration?
No, you can't. You can't. It's not
Okay,
uniform.
sir.
I'll draw a graph and show you its acceleration is not uniform. It reduces with the time. With the time, velocity increases. With the time, acceleration reduced.
Okay, sir.
Okay, Buddha. Right. I won't give a small note about these things. What are the other questions that they have asked? They have asked us to, the question asked us to find acceleration, resultant force. Any other questions here?
So there is
Any
one
other
more
question?
question, sir.
Yeah, please read it there.
What is the velocity of the sphere when the resultant force acting on it is 0?
Okay, very good. Right. So that is question number 4 or 5. Please tell me the question number also.
So 6, sir.
Right. Please wait. Please write Roman number 6. Question number 6. Roman number 6 and write Roman number 6 and please write. According to the above calculations, it is confirmed that. According to the above calculations, it is confirmed that the resultant force acting on the sphere is reduced. Resultant force acting on the sphere is reduced when the velocity of the sphere is increased. When the velocity of the sphere is increased. According to the above calculations, it is confirmed that the resultant force acting on the sphere is reduced when the velocity of the sphere is increased. When the velocity of the sphere is increased. Full stop. Therefore, the resultant force acting on the sphere, becomes 0. Therefore, the resultant force acting on the sphere becomes 0 at a certain velocity of the sphere. At a certain velocity of the sphere. Therefore, the resultant force acting on the sphere becomes 0 at a certain velocity of the sphere. Clear? Okay or not? Would like if I repeat the note? Anybody in the class?
Yes, sir.
Yeah, let me repeat. According to the above calculations, it is confirmed that the resultant force acting on the sphere is reduced when the velocity is increased. Resultant force acting on the sphere is reduced when the velocity is increased. Full stop. At a certain velocity of the sphere, at a certain velocity of the sphere, comma, the resultant force becomes 0. At a certain velocity of the sphere, resultant force becomes 0, or resultant force becomes 0 at a certain velocity of the sphere. Got it? Right. Continue. That velocity is known as, please write, that velocity is known as, look at board and write, that velocity is known as terminal velocity. Look at board and write. Terminal velocity. That velocity is known as the terminal velocity. It's better if you use a different color pen. Right? So when velocity increases, resultant force reduces. At a certain velocity, the resultant force acting on the sphere is 0. That velocity is known as the terminal velocity. That velocity is known as the terminal velocity. Look at both these. So now I'm going to consider the terminal velocity. So U equals terminal velocity. At the terminal velocity, the resultant force is 0. The resultant force is 0 under the terminal velocity. Right? So now we are going to find this velocity. Terminal velocity is normally indicated by U with capital T. Right. So please write this equation. Please write this equation. U equal terminal velocity. Then the resultant force is this equation, and resultant force is 0. Please write this equation and try to find ut. Ut is the terminal velocity. You will write here. Write this and try to find the terminal velocity. Start. Let's take this term to the other side. The minus term can be taken to the other side as positive term. So then this part 1.32 into 10 to the power minus 2 times u terminal will be positive once it is taken to this side, and nothing will happen to I do not change anything in 1.68 10 to the power minus 2 number. So therefore u terminal, the terminal velocity of the sphere equals 1.68 into 10 to the power minus 2 divided by 1.32 into 10 to the power minus 10 to the power minus 2 and 10 to the power minus 2 cancelled out. What is this number here? What is this terminal velocity? Somebody please tell me. Have I written all the numbers properly?
1.27.
1.27, right? 1.68 divided by 1.32. Yeah, 1.27 meter per second. So approximately 1.3. 1.27 meter per second. Who got this answer? Who got this answer? Right. So what is the speciality of this terminal velocity? When we increase the velocity, when the velocity is increased, resultant force decreased. So at a certain terminal velocity, resultant force becomes 0. Right? The velocity at which the resultant force is 0 is known as the terminal velocity. So terminal, until the object reaches to the terminal velocity, the velocity increases. Right. Now my question is, will the velocity be increased after the terminal velocity? Somebody please unmute the mic and tell me.
No, sir.
Yeah, dear. Somebody please tell me whether it is possible to increase the velocity of the sphere greater than the terminal velocity.
No, sir.
No, sir.
So it means terminal velocity is the maximum velocity. Velocity cannot be increased further. I can prove it like this. I can prove it like this. Look at board. Look at board. I want to erase this side. So if you want, please take a screenshot. I want to erase this side. Quick. Right. Let me use this symbol FR for the resultant force. Let me use the symbol FR for the resultant force. Right. Now, when the velocity is 0.1 meter per second, what is the resultant force? Somebody please unmute the mic and tell me. We have found this data. Just tell me here.
1.548 into 10 to the power minus 2.
1.5. Can put the 1.5.
48 into 10 to the power minus 2.
1.548 into 10 to the power minus 2 Newton. Am I right?
Yes, sir.
Then what is the resultant force acting on the sphere when the velocity is 0.2 meter per second? Tell me.
1.416
Into 10 to the power minus 2 Newton. Am I right?
yes sir.
Yes, sir.
Then what is the resultant force acting on the sphere when the velocity is 0.3 meter per second?
1.284
284.
1.284 into 10 to the power minus 2 Newton. Correct or wrong?
Correct, sir.
correct sir.
Then what is the resultant force acting on the sphere when the velocity is 0.4 meter per second?
1.152 into 10 to the power minus 2 newtons.
1.152 into 10 to the power minus 2 Newton. Correct or wrong?
Correct, sir.
Correct. Now my question is, what has happened to the velocity?
1.152, right?
1.15. Now my question is, what has happened to the resultant force acting on the sphere when the velocity increases speed?
Decrease.
Reduce, nil.
Decrease.
So like that, finally, when the velocity is 1.27 meter per second, what is the resultant force speed? Eh?
0.
Tell me dear, somebody unmute the mic and tell me.
0, sir.
0, sir.
0. So I would like, if you note this, please write this, because I'm going to draw 3 graphs. I'm going to draw 3 different graphs. All the 3 graphs asked in the examination. You have to be okay. So please write hello. Can you see him? You want to eat something? Don't bite my fingers. Can you see the sphere?
Yes, sir.
He thinks that I am teaching to him. That's why he thinks that I am talking to him. He can't see any persons here. Like I give something him. So please write all the things that are written in black color. Write them all. Right. If I draw a graph between the resultant force acting on the sphere and the velocity of the sphere, what will be the shape of that graph be? What will be the shape of that graph? If I draw a graph between the resultant force and the velocity, velocity of the sphere and the resultant force acting on the sphere. When the velocity increases 0.1, 0.2, and finally, when the velocity is 1.27, resultant force is 0. Right? So initially, we are at the very beginning, there is a certain resultant force, but resultant force, let me take this value here, 1 point is something. Resultant force, when the velocity is 0.1, resultant force is 1.548 into 10 to the power minus Newton. So we draw this graph. The shape of this graph will be a curve, something like this. Right, please complete this graph here. Please draw this graph. The graph which shows the variation of the resultant force with the velocity of the sphere. Draw it. What will be the shape of the graph if we draw a graph between velocity and time? This is time measured in seconds. This is velocity measured in meter per second. What will be the shape of this graph here? Velocity increases 0.1, 0.2, 0.3, and finally it reaches to 1.27. Right? So with the time, velocity increases up to 1.27. Once the velocity reaches to 1.27, the velocity will not be further increased. Velocity will not be further increased. Therefore, 1.27 is the maximum velocity. When the velocity is 1.27, resultant force is 0. Resultant force is 0 means there is no acceleration. No acceleration means no change in velocity. Right. So once the velocity of the sphere reaches to 1.27, its velocity remains unchanged. Right. So shape of the graph will be something like this. This part is a straight line. Draw it here. So maximum velocity achieved by the sphere. Maximum velocity achieved by the sphere is 1.27. That velocity is said to be the terminal velocity. If you have any doubt, just send me a message to Zoom, I can answer. Somebody unmute the mic and tell me the dimensions of this neta constant. Neta is known as the coefficient of viscosity. So somebody please unmute the mic and tell me. Last week we have found it, the dimensions of neta.
Sir, m l minus 1 t minus 1.
M L minus 1 T minus 1, sir.
Let's see. You should give me the correct answer, right? What is it? The dimensions of neta is m
L minus 1 t minus 1.
ml minus 1 t minus 1. So others please confirm this here. Other students please confirm this. Correct or wrong?
Correct, sir.
Then what is the SI unit of neta?
kg ms minus 1 s minus 1.
kg
m minus 1 s minus 1.
m minus 1 is minus 1, but there is a simple unit than that. Didn't I give this one? Newton seconds
Newton
per
second
square
per
meter?
Newtons per second.
Didn't I give this Newton seconds per square meter? Check.
Give, sir.
So I would like if you because we have reached the end of this coefficient of viscosity case. Therefore, I would like if you write this note also once again. It will help you to remember the coefficient of viscosity. The coefficient of viscosity. Write them all there. Write the note. Right, I'll send you a past paper question to the WhatsApp group. You try it at home. And if you do not have enough knowledge to do that past paper question, because some beginnings part will also be needed. right? So you have to join to Tuesday night class if you do not have enough knowledge, enough mechanics knowledge to do that one, because it's a combination of units, dimensions, and mechanics. So try to do it at home, but if you think it's difficult, the best thing is join to Tuesday night class 8 to 11. Right, now please take a vernier caliper section. I want to complete that one. Right, so like this we should slowly discuss more questions for units and dimensions lesson. We have discussed more questions for units and dimensions lesson. So covering syllabus means not missing the things. Teaching incompletely is not covering the syllabus earlier. Okay, like take a vernier caliper note and tell me the final thing that I have written in a vernier caliper.
So we have done the reading sheet questions, sir.
How many questions have we discussed here?
2 questions, sir.
Right, look at board. I want to teach you something. Only 2 questions. Are you sure?
So as homework, you gave another 8, sir.
All right, let's discuss some of that questions in the reading sheet number 1. After that, let's go to the theory. So you can write the answers in your theory note. Take vernier caliper note. So it means actually we are using the same book. Half of the book for units dimension, the other half for the vernier caliper. Let me show you the vernier caliper reading sheet number 1. Wait. Can you see the reading sheet number 1, dear? Right. We have discussed the first 2 questions. We have discussed question number 1 and question number 2. Let's go to question number 3. So according to question number 3, you should see this 21 centimeter line. Now somebody unmute the mic and tell me 21 centimeter means how many millimeters?
210.
210 millimeters.
210 millimeters.
210 millimeter. Now what is this length then? Here, you see my arrowhead, mouse point. What is
1
this
millimeter.
200 words.
210
Words.
millimeter plus 1 millimeter, 211 millimeter. This is 210 millimeter. 21 centimeter means 210 millimeter. So what is this then?
211.
211 millimeters.
211. Then what is this?
212 millimeters.
212 millimeters.
What is this then?
213 millimeters.
213 millimeter.
14, sir.
214. 214, sir.
11, 12. This is yes. This is 13. This is 13. Wait. Yeah. This is 11, 12, 13, and this is 14. Am I right? So what
Yes,
is this
sir.
value here?
Yes, sir.
214 millimeters.
214 millimeter. Right. Look at board. Look at here. This is the vernier scale 0 line. If we start from the vernier scale 0 line, if you start from the vernier scale 0 line, and if you try to travel towards the main scale 0 line, right? What is the first number that you find on the main scale?
240.
240.
240.
Right. If you start from vernier scale 0 line, if you try to travel towards the main scale 0 line, the first number that you find on the main scale is 214. Therefore, this 214 is said to be, somebody please tell me.
Main scale reading,
Main
sir.
scale reading.
It is said to be main scale reading. Then according to this, what is the coincide vernier now? This is 0, 1, 2, 3,
5,
4,
sir.
Sir, 5.
5. What is the coincide vernier number? 5.
5, sir.
What is the letter normally used to indicate coincide vernier number?
Capital N, sir.
So capital N is 5. Got it? So if you want, please take a screenshot of this. This will help you to understand. Wait. Right. If you we have erased everything there. Right. Okay. I think, but I think it's okay, right? No. Everything is there. If you want, please take a screenshot. Now somebody unmute the mic and tell me what is this distance here? The distance between 0 centimeter line of the main scale and 0 line of the vernier scale. This length is said to be
The capital R.
Reading.
capital R. Capital R is used for
Reading.
reading. Very good. Okay. Right. Let's try to draw it. Let's try to draw it. There are two methods to find the reading. What are the two methods here? We can obtain the reading just by just looking at the figure, by marking lengths on the figure, we can find the reading. Or there is an equation. We can use that equation to find the reading. So as this is the second day, let me use both equations. So if you want, please take a screenshot because I'm going to erase everything that I have written on the board. So if you want, please take a screenshot. Right. So we are going to find the answer for reading sheet number 1. Question number 3. If you start from the main scale 0 line, and if we go to the right hand side, we will find this 21 centimeter line. 21 centimeter means 210 millimeter. After that, we will find 211, 212, 213, and 214. Just after 214 line, just after 214 millimeter line, we are able to see the vernier scale 0 line. Right? So therefore, this is said to be the main scale reading, that is 214 millimeter line. The coincide number is 6. No, 5. Neil. Coincide vernier number is 5. 1, 2, 3, 4, 5. 6 is also there, but 5 is the coincide number. So this is 14, 15, 16, 17, 18, something, this number may coincide. So coincide vernier number N is 5. We don't worry about the main scale coincide number. We worry about only the main scale, sorry, vernier scale coincide number. The gap between the 2 0 lines, this gap between the 2 0 lines is said to be the reading. Is said to be the reading. Okay. Look at board. Look at board. Draw this figure. After that, let's discuss it. First of all, please draw this figure. You can use a theory note, right? Just draw it. Did you draw it here? We have found this x as 0.9 millimeter. X is the length of a main scale section, that is 0.9. Look at the main scale and tell me the length that I have marked with this red color line. What is this length here according to the main scale? Somebody in the class?
219 millimeters.
219 millimeters, sir.
219 millimeter. Very good. According to the vernier scale, what is the gap between these two red colored dotted lines here? R plus 5x. Am I right? So I can write that according to the figure, R plus 5x equals 219 millimeter. According to the vernier scale, this length is R plus 5x. According to the vernier scale, that is 219 millimeter. Can you do the rest and find R here? Sometimes you may have obtained the answer, but I'm really happy if you write my answer separately with this very big figure. Got it? Right, look at board here. So R equals 219 plus 5x come to this side as minus 5x. So 219 minus 5, x is 0.9 millimeter. So 219, 5 times 9, 45, and 1 decimal point should be removed. 1 decimal point should be removed. So 4.5. So if you subtract, you have to take 1 to the side. 10 minus 5 is 5. This is 8. 8 minus 1, 4 is 4. 214.5 millimeter. Who got this answer? Who got this answer? 214.5 millimeter. But we should not keep the answer like this. We should write one more step. One is 2 more steps. What should we do next year?
Centimeters.
Do something first.
Convert to centimeter.
Convert into centimeter. Very good. 214.5 millimeter divided by 10, then millimeter converted into centimeter. So then this is 21.45 centimeter. Who got the answer up to centimeter here? Anybody in the class? Right, but there is a very simple method than this to obtain the answer. What is that method here? It's a so simple method to get the answer. What is it? Somebody?
Equal NSR
Using the equation.
VSR.
Using the equation. Yeah. So let me use that method. Second method. And this is the method that we used in the examination. According to second method, reading equals main scale reading plus vernier scale reading. Vernier scale reading is given by the equation least count into point side vernier number. Right? So main scale reading is the value that you find on the main scale when you try to go towards the vernier main scale zero line. You start from the vernier scale zero line. You start from the vernier scale zero line and you try to go towards the main scale zero line. The first value that you find on the main scale is said to be the main scale reading, that is 240. Least count we know 0.1 millimeter as we found it. coincide Vernier number is 5. Coincide Vernier number 5. So you get 214 plus 0.5. So that is 214.5 millimeter. If you divide this by 10, you get 21.45 centimeter. Right. So please write the second method also. Very simple. Second method is very simple and it's easy to use. Okay, dear. Hello.
Okay, sir.
Yes, sir.
Okay, sir.
Okay, sir.
So what do you think about this class? We teach 3 hours. We teach 3 hours. Units, dimensions, measuring instruments. Every week, 3 hours of time period used for units, dimensions, and measuring instrument. Then Tuesday night, another 3 hours we separately use to teach mechanics. Sunday morning, 9 to 12, there is a paper and tube discussion class. And not only the physics, we have arranged a free seminar series for chemistry with the best teacher. And there is a free seminar series for maths with the best combined maths teacher. And both of them have started permanent online classes for chemistry and maths. Physics 9 hours per week. And you have the best chemistry teacher with the best maths teacher. What do you want further? What do you want further? Inna vera innum dear? What should I ask? What should I ask? I should ask from you. Inna vera ennum. Am I right? I should ask from you. Inna vera enna venum. What do you want further? You should take a island rank. And this Friday morning, chemistry teacher will start his online classes. What's the lesson that he's going to teach? Somebody please unmute the mic and tell me.
Chemical calculations.
Chemical calculations, sir.
Chemical calculations. What about that? Hydrogen
Chemical
spectrum?
calculations plus hydrogen spectrum.
Yes, dear.
Chemical calculations plus hydrogen spectrum. Both
Chemical
theory and physical
calculations plus
in parallel.
hydrogen spectrum, right?
Yes, sir.
Yes,
What's the class time duration here? Friday. Starting time, did he inform you?
9 to 12 something.
At 10,
9
sir.
to 12.
10 to 1. 10 to 1.
10 to 1 or 9 to 12? Confirm it.
9 to 12, sir.
Sorry.
9 to 12. So Saumika sir told you that he will start his chemistry class this Friday, 9 to 12, right? And there will be hydrogen spectrum, a further discussion about hydrogen spectrum and chemical calculations. Is it correct?
Yes, sir.
Yes, sir.
Yeah. So you please join to that chemistry class. I think he will not ask you to pay the class fees at once because we are in the pandemic situation. I'll talk to him if he says something like that. What about the trigonometry lesson, dear? Did you join to the trigonometry lesson? I forgot to ask it. Who
Yes,
joined
sir.
to trigonometry lesson? Who joined to the trigonometry class? No, are there any math students?
I joined, sir.
You joined. Please tell me the date and time of the math class, dear. Trigonometry lesson.
Monday 9 to 12, sir.
Monday 9 to 12. So with interval or without interval?
Without interval,
Without
sir.
interval, sir.
ඒක තමයි. One answer කිව්වා මේ ළමයිට interval දෙන්න එපා කියලා. මොකටද interval? So no need interval, no need break. So maths teacher will also teach you from 9 to 12 Monday morning trigonometry. Am I right?
Yes,
Yes,
sir.
sir.
I really hate when a teacher gives an interval because I don't like to give interval. we are here class to learn, not to have an interval, not to break. Right. So please join to the trigonometry class because it's very important. You can't get A for maths without trigonometry. And I have asked teacher to send the recordings of last 1 week or 2 weeks. How many weeks that he taught this lesson, dear? Trigonometry?
2, sir.
2 classes. 2 classes. If let's say a new student join to trigonometry class from next Monday, will you help him or her by sending notes and other things, dear? Who promised to help?
Yes, sir.
Okay, please help. Always help others, dear. If you help other humans, God will help you back. What's the point? You help other humans with your knowledge and with your skills and with your abilities. Then God will help you back. That's the point. So all the other students join to the trigonometry class from next Monday. I'll ask her to share and I will ask our class admin to share the recordings of last 2 classes. Right. Chemistry class will be there Friday 9 to 12. Right. Shall we go to our third? This is third. Let's go to our 4th example. After that, I want to teach you something further. Right. Please take a screenshot, dear, because I want to erase. So we have provided everything. We have provided everything, right? I should ask this same thing again. What is it? Innam vera enna venum. That's what I want to ask from you. What do you want further? Right. Okay. May I erase? Please give me the permission to erase.
Okay, sir.
Okay, sir.
Right. එහෙනම් දරුවනේ අපි යමු ඊළඟට මම වීඩියෝ එක ක්ලෝස් කරලා ස්ක්‍රීන් එක ෂෙයා කරන්න. නේද? You can learn that many Tamil from Vadivel. It's the best teacher to learn some Tamil. Right. This one. Question number 4. Can you see the board?
Yes, sir.
Yes, sir.
Yeah. What is the 6 centimeter mean? How many millimeters? Somebody?
60 millimeters, sir.
60 millimeters.
Then what is this here? 61.
61 millimeters.
This is? You have to talk to me.
62.
62 millimeters.
This is? This one?
63 millimeters.
63 millimeters.
This is 64
4 millimeters.
millimeters.
This is?
65 millimeters.
Then
66 millimeters.
this is?
67 millimeters.
So 67 millimeter is the number just before the vernier scale 0 line. Therefore, what is the main scale reading there?
67 millimeters.
67 millimeters.
millimeters, sir.
Main scale reading is 67 millimeter. Wait, it's somewhat difficult, right? Now okay. 67 millimeter. What is the coincide vernier number?
6, sir.
6.
6 near. 1, 2, 3, 4, 5, 6. So this is the coincide vernier number. What's the letter that we normally use to indicate coincide vernier number?
Capital N, sir.
Capital N. I want a small help there. Can somebody take a screenshot of this and send to our class admins or groups? Then we can share it. Please take a screenshot of this and send to one WhatsApp groups or to the class admin there, please. Actually, it is normally in normal Tamil, it is just said where in the venu. Normally, it should be said as where in the venu. When Vadivel is talking, he is add another word innum. He start saying innum where in the venu. So different, right? Right. Yeah. Let me stop the screen sharing and let's try to draw it on board. Right, sorry. Right, look at board. I know that students are tired, but don't leave the class there because you have to work so hard to achieve your dreams. Dreams will be dreams forever if you do not work hard. That's the problem, right? So if you think that you are tired, I am the person with the maximum time because all the 7 days I work. All the 7 days I work. Right? Only for 23 days, I worked 9 to 12 hours per week. So then what about 21, 22 then? So please don't say that you are tired because I am more tired than you. Right? So if I draw question number 4, you will see this, there should be 0 centimeter line somewhere here. But I think, but it is not given in the question paper. Right? It is, it's just show you the 6 centimeter line. 6 centimeter line is the point that they have started. 6 centimeter line means 60 millimeter. After that, 61, 62, 63, 64, 65, 67, 67, right? Yeah. So there will be up to 67. So we have marked this main scale reading as 67 millimeter. After that, there will be the vernier scale 0 line. Coincide vernier number is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Am I right here? Please tell me whether I am correct or wrong here. Is the coincide number 6?
Yes, sir.
Yeah. According to main scale, what is the coincide number? 1, 2, 3, 4, 5. No. You can start from 7. So 1, 2, 3. Yeah, the third one. Am I right? Right. So coincide number is 6. N equals 6. So here I'm not going to use the this figure method. I need to use the second method. So reading equals main scale reading plus vernier scale reading. Vernier scale reading can be found by the equation least count into coincide number. Main scale reading is 67 millimeter. Least count 0.1 millimeter. The coincide number is 6. So 67 plus 0.6. So then the answer is 67.6 millimeter. Who got this answer at home? Who got this answer at home? Anybody in the class? But this can be slightly simplified. We can write one more step. What is it here? Somebody?
Convert into
0.76
By
centimeters.
dividing by 10.
Divided by 10. Then millimeter converted into
centimeters.
Centimeters.
centimeters. So 67.6 divided by 10 millimeter is centimeter. So it will be 6.76 centimeter. Got it? Please draw the figure and write the answer. Okay. Shall we go to next question here?
Okay, sir.
Okay, sir.
Thank you, Himaya. The students will be motivated if you send the same message to that can be seen for everyone. I'm really happy. Thank you very much. This is what we earned here. I would like to take a screenshot of your message and send show to my mother, so she will understand that we are not teaching only for money. So this is what we get. Yes, thank you, Himaya. Actually, I wanted to buy a new phone and create some new WhatsApp groups, but but unfortunately, I was not able to do it yet. Right? I think students know that I fell down in and still health is not okay. Still, many of body parts fading, including the neck. Right. Shall we go to next part of the next question? Yeah, then we should complete this reading sheet 1 because there are so many other reading sheets. Please give me the permission to go to next question.
Yes, sir.
Okay, sir.
sir.
Okay, sir.
Thank you, my dear students. I really love you all. Let's go to the next question. Right, question number 5. Can you see it?
Yes, sir.
Right. From question number 5, we are not going to draw figures. For question number 5 and 6, we are not going to draw figures. We are going to take screenshots. Let's use the technology. Right. What is the main scale reading? 4 centimeter mean how many centimeters dear? How many millimeters?
40 millimeters, sir.
Millimeters, sir.
40 millimeters. 4 centimeter means, right? 40 millimeter. So after that, what should we do? We should go until we find the vernier scale 0 line. What is this dear?
41
41
millimeters.
millimeters, sir.
This is
42.
42 millimeters, sir.
this.
43
43 millimeters.
This is
44
4 millimeters.
this is.
45 millimeters.
So So just after 45,
45
we will
millimeter.
find the vernier scale zero line. Then somebody say, tell me what the main scale, what the main scale reading is.
45.
45
millimeters.
Main
5 millimeters.
scale reading is, yes dear, 45 millimeter. Now somebody unmute the mic and tell me the coincide vernier number.
5.
5, sir.
5, sir.
5,
5.
sir.
Coincide vernier number is 5. What's the letter that we use for it here?
Capital N.
Capital N.
Capital N.
Capital N is 5. Then how do you find the reading? What is the equation that we use to find reading?
MSR
Main
plus
MSR plus
capital N.
PCR.
MSR plus VCR. What is VCR, dear?
Vernier scale reading.
Vernier coincide readings, sir.
Vernier scale reading. What is VSR, everybody?
Vernier scale reading.
Vernier scale
Vernier scale reading. Alla bulla. Very good. Main scale reading is 45. Please write, put question number 5 and write. No need to draw a figure because figures are already given. 45. Main scale, vernier scale reading is least count into coincide vernier number. So please write like this because no need to draw a figure because figures are already given. We have drawn a few of the figures for us to understand. So this is 45 plus least count is 0.01 millimeter and coincide number is 5. Coincide number is 5. Okay, so then we get,
So least count is
45.
0.1. No?
sorry dear.
So is
Sir,
it
how we
0.01 or not?
Least count should be
Yes,
Sir, the least
0.1.
count.
0.1. Yes, yes. What is least count here? 0.1. Yes, yes, mistake. 0.1. So what is 0.1 into 5 then? 0.5.
0.5.
0.5, sir.
Then what's the final answer?
45.5
45.5, sir.
Unit?
millimeter.
Millimeters.
Millimeter. Very good. What are the other things that we should want to learn in vernier caliper? This week we were not able to complete vernier caliper because we had a big question in dimensions lesson, and I should send you the past paper question from that dimensions lesson, right? If I forgot, please send a message to class admin, right? If I forget to send you the dimensions past paper question with the theory that we have learned today, please send a message to class admin, right? Sometimes I will forget. So I can remember physics, but I can't remember the other things. So that's one of the upsets. Right. So final answer is 4.55 centimeter. So the next thing that we should learn is positive zero error of the vernier caliper, negative zero error of the vernier caliper, and other vernier scales. There are some other vernier scales, especially the extended vernier scale. Who has heard about extended vernier scales here? Anybody in the class? So that's very important, right? So we should learn. Actually, positive zero error, negative zero error is nothing. They are very simple. They are very simple. But extended vernier scale and other major 4 vernier scales must be learned very well with the past paper questions, right? So we should learn things completely, not half. We are not in a race. If we say that we cover the syllabus by teaching the things half, I think that's not good. That is, if those things are asked in the examination, you will be in a big trouble in the exam. Right. So we have completed 5 questions Could you please take a screenshot and send these to our WhatsApp groups? That will be a big help for all the students.
Already I sent it, sir.
Okay, thank you, dear. Thank you, dear. Right, so please
You're
try
welcome,
question.
sir.
And the other thing, you can answer only up to question number 6. You can't answer question number 7. Tell me the reason. You
So
can't
because
answer
there are
question
20 vernier
9,
divisions.
10. Why? What's the reason? Somebody please tell me.
So because there are 20 vernier divisions.
There are 20 vernier divisions. You have learned only up to 10 vernier divisions. So you can't answer those questions. Right. If we go to the other questions, you see that you see that there are 20 vernier divisions if you check. So as you have not learned up to 20 vernier divisions, you can't do it. If you go question number 9, how many vernier divisions are there?
50.
50.
50 vernier divisions are there. So you can't answer that one. What about question number 10? Again, there are 50 vernier divisions. So you can answer only up to 6. So next week, I'll teach you the vernier scales with 20 vernier divisions, 50 vernier divisions, 49 vernier divisions, extended vernier scales, and positive, negative, 0 errors. So I think we'll be able to complete vernier caliper theory next week. But there will be so many reading sheets, so many other questions for the vernier caliper. Got it, dear? Okay. Right. I think that's enough for today. Right. I wish you good luck. And again, I remember you to join to the chemistry and combined maths classes. I just and the other thing, I just want some island ranks from math sections. Bio, we have already obtained many island ranks, and I think bio students, they do not have any problem. They are doing well. Right. So that's enough for today. I'm also tired now. See you. Bye.
Thank you,
Yes,
sir.
sir.
Thank
Bye.
you,
Thank
sir.
you,
Thank you, sir. Bye,
Thank
sir.
you, sir. Bye, sir.
Thank you, sir.
Have a good day, sir.
Thank you, sir. Bye, sir.
Okay. Good luck.